All right, in this session, we're going to discuss fixed wireless access as a 5G revenue generator, and I'm excited to welcome Maryam Rofougaran, the CEO and co-founder of Movandi. So thank you for joining us, Maryam.
Hi, thank you. It's nice to be here.
So before we get into fixed wireless access, I was hoping that you could give our audience just a little background on Movandi, your millimeter wave technology, and some of the specific applications that you're working on.
So Movandi is a disruptive company that was founded to enable real potential and promise of 5G and create all these new applications. So Movandi has focused on millimeter wave because there's a huge bandwidth in this spectrum, and that's required for the real promise of 5G and enabling some of these major applications that we talk about. We have focused on the design and development of deep semiconductor technology powering 5G and beyond, interconnecting our world and enabling AI applications across multiple industries. We have pioneered wireless RF systems, and we are solving the real-world 5G millimeter wave deployment challenges, and we're providing some technology unmatched differentiations and high-performance core 5G technologies in RF antennas, IP, and unique engineering methodology that enables service providers and industry partners to launch indoor, outdoor, as well as mobile enhanced 5G millimeter wave services at 50% lower cost. So we are a fabless semiconductor core technology RF system company that are providing what is required to go build solutions with partners in some of the advanced devices, as well as providing some unique and differentiating systems that are helping with lowering the cost of deployment.
All right, I appreciate that overview. So now on fixed wireless access, this in the US market at least has been very much associated with millimeter wave, given that Verizon's initial go-to-market with 5G was their 5G home millimeter wave fixed wireless access service. And since then, we've seen not only their service expand, but interest in fixed wireless access just globally kind of gaining traction. I'm curious, though, most of what we've seen today is dense urban. Maybe you could talk to us about the role of millimeter wave fixed wireless in different deployment areas, suburban or even rural.
Yeah, so this is actually very interesting because, again, the perception and the wrong image of millimeter wave not being able to go far has so far limited to the places that are dense and short range. But in reality, if you look at some of the experiments and some of the trials that have been done, both we have done some of it ourselves, the ranges actually could go far. I mean, so far the challenge has been that the devices have not been available, or if they were available, they were too expensive. So look at it. The need for providing internet access to everyone, especially during this whole pandemic, everything became clear that, it's really unfortunate that 1/3 of the households in the US still don't have internet access, right? Only 20% of some of these urban areas have access to internet. More than 4.4 million children did not have access to internet and could not do much work during this pandemic. So there is definitely clear need for fixed wireless access, because you can see that fiber has been there. Fiber is not something new. It's been around, but there are challenges with it. They are expensive to go far, and also in some places it's not even possible to reach that far. So, and it requires digging, permission. So fixed wireless access, if it can be done right, that's the right solution. And again, fixed wireless access is not something completely new either. It's just that now with millimeter wave and 5G coming along, there is a huge potential to actually take advantage of it and try to provide internet access to everyone, and basically close this gap and close this digital kind of the difference that, some people have it, some people don't have it. So now, after many years, the cost with the advances in the 5G millimeter wave, the cost has come down a lot, and the devices have become more powerful. And with what we're doing, in addition to that, providing solutions that don't even need fiber backbone and extending the range, it's going to become a lot easier, and it's going to become a lot more affordable to be able to provide internet access via fixed wireless to even rural areas, and that's a necessity. So if you look at it, look at the predictions that some of these research organizations have made, and it's true because we see it globally. We're working with different operators in different countries, and we definitely see that the demand for fixed wireless access is growing. And we do see some of this research coming up and saying, for example, the research and markets predicts that the fixed wireless access market will grow from 823 million last year to 3.3 billion by 2026. And this is something that we're actually observing. We do see globally a lot of interest coming toward fixed wireless access.
Yeah, let's talk more about global interest in millimeter wave, in general, really fixed wireless access and other applications. I gave the example of the U.S. just because the spectrum was made accessible to operators quite early in the arc. But if you look around the world, well over a dozen markets that are at various points in the process of auctioning, allocating, and deploying millimeter wave spectrum. So just, what are your expectations in the next few years as operators are able to deploy this spectrum? What do you think they're going to be focused on using it for?
I think I'm actually looking forward, and I see that, as I mentioned, that globally fixed wireless access continues to be one of the main drivers. We do see that happening in different areas. I mean, now Australia and other countries are coming up, and this is going beyond just dense areas. I'm hoping to see a lot more of that happening, extending the range into urban areas, providing a lot of internet access and facilitating some of the challenges that had existed before. Imagine, if you could provide educations via AR, VR, making it real kind of experience for students at home, no matter where they are. And these are the kind of stuff that people are actually looking into. They're trying to make this happen. So fixed wireless access is definitely one of the first applications that I do see globally. Beyond that, we're looking at other applications that go even beyond that, even going to mobility, but dense areas for sure, like airports, stadiums, venues, malls are the ones where you really need a lot of capacity support, and nothing can do as well as millimeter wave can do, for sure. For example, we have actually experienced in one of these stadiums, Phoenix Sun, where without the millimeter wave, when there was crowd in that area, basically your internet or your access would go almost to zero. And when you had the millimeter wave and we're using our repeaters to extend that, we could see that you could keep the connection even when the crowd is there, and you could easily go above 100 megabits per second, etc. So these are applications that will be used. You will see them globally as well. But the other new thing that's coming up, and I'm hoping to see a lot more of that, is private network. We're actually starting to see private network and some of these applications globally coming up, and different operators have started already doing some trials and starting to expand these applications in their countries. So globally, we do see this thing coming up, and we see a lot more applications coming up because the auctions are there and the licenses are provided to more operators.
And Maryam, I've got 3 questions from the audience here, and they're all really around propagation characteristics. So maybe you could just give us a little bit of detail on what type of coverage Movandi is seeing in the field.
This is actually a really, really good question, and I think I should have gotten to it before. But everyone knows as you go to higher frequencies, the millimeter wave, because of the wavelength, etc., you have to deal with the penetration issue, meaning that you're going to have issues coming into the building, and you have less range because apparently you lose more of the energy as you travel. So those are the fundamental challenges or physics challenges that exist with millimeter wave. Otherwise, everything else is perfect. There's nothing that can beat millimeter wave performance for this kind of application. So this is exactly what we have focused on, and this is exactly what we have been trying to address, because with the penetration, with the coverage issues that exist, if you have a blockage right in front of you, no matter how much power you're putting, it basically gets blocked, and there you go, your coverage is gone. So the cost of deployment could become huge if you have to go and put base stations or small cells that require fiber and bring the fiber in and put it in every 100 meters to be able to address these buildings or blocks that are in front of you and provide coverage. So what we have done and the solution that we're providing is that you can look at these very small devices, one box, indoor, kind of the ones that are for indoor or even outdoor, but it's just one box, small boxes, no fiber. So we call them smart repeaters, and these smart repeaters, what they can do is that they can get the signal. They basically can scan, they can find the right base station, the right operators. They're smart enough to sync to the base station, so they don't just randomly create noise in the environment. They amplify the signal and they extend the range beyond where it could be. So they could be, because they're small and they're very low cost, they can be put anywhere, on the roof, on the wall, on the poles. So this helps a lot with the penetration, because basically if you put it behind a window, for example, inside the building, it gets the signal and it makes sure the signal comes in and you provide, you spread the signal inside the building. We have done that. We actually have done some places where we have a huge area with a lot of blockage inside, and we've been able, with a few of these devices, we've been able to bring the signal inside and make sure that you get higher than 1 gigabit, or actually more closer to 2 gigabit per second everywhere in that building. So the cost of deployment using these devices drastically reduces, because you don't need fiber, and these are very, very low cost solutions. And they could be both used indoor as well as outdoor. So that's what we're trying to help, and it's it's becoming part of this whole deployment.
Yeah, you raise a really interesting point, and maybe we should put a kind of a bullet on it. But several years ago, the scrutiny on millimeter wave was all on the technology. You can't make this a viable mobile technology. That's all been kind of proven out as the devices and the radios have matured. So now there's the scrutiny that's on the business case, and we've got a session later in the program that's going to demonstrate clear ROI for a localized millimeter wave deployment. But just to the bigger economic picture, operators, they're going to have to go to millimeter wave eventually, because that's where the capacity is. So then the logic just goes down to the network economics, and that's where these repeaters come in. So maybe just tell us a little bit more about what the addition of a repeater to a network topology does for that economic logic.
So again, going back to what the ROI is basically done based on the return on investment is based on your capex, the deployment costs, as well as the the gigabyte per second costs, and also the time that it takes and the effort that it takes to basically deploy the solution. So if you look at millimeter wave again, because of the challenges that everyone talks about, the coverage, penetration, if you go and want to go build a network and make sure you have enough coverage just using the base stations and small cities, it's going to be enormous cost and almost impractical, even for dense areas, I would say. So to bring this cost lower, that's what we have been trying to help this area, right? We have come up, we're building solutions with our partners that, again, we're providing the technology inside, the enabling technology, and working with our ODM partners, like with WNC, we just built a dual band indoor repeater where it supports both 28 and 39 gigahertz. So it's one box, it's could be used for either one of these frequencies, and very, very low cost. And it's very important because especially, you know, both outdoor as well as indoor, if you cannot provide solutions that are very cheap and very easy to install, it takes only a few minutes to set it up. There's not, it's going to be not that cost effective, especially if you're trying to compete with solutions like, you know, Wi-Fi, etc. But these devices are really low cost. They can be meshed so that you can actually get the full coverage between and the complete coverage inside the building using the mesh network of these devices. So if you look at it this way, you can either use these devices to get the signals inside, or you can have a small cells complemented with this kind of repeater solution and bring the cost and the deployment per square feet inside these buildings to so much lower that it becomes very affordable, and it becomes 50% lower than what it would be without using these repeaters. We are also doing the same thing for outdoor. And we are providing this kind of repeaters in a different, again, same technology with different ODMs and different configurations to be able to provide different applications. So we can extend the coverage outside, in malls, as well as indoor for applications like, you know, whether you want to use it for similar to Wi-Fi inside buildings, but with much higher capacity and lower latency, because, you know, other technologies have limitations. Millimeter wave really can address all these challenges. So, so if you put all these things together, we're bringing the cost of the deployment 50% lower by providing solutions that we have brought to market with our partners.
50%. That is a very compelling savings figure. And Maryam, I really appreciate you taking the time to join the 5G Monetization Forum and tell us about the work Movandi is doing to help operators leverage millimeter wave to create new service revenues. So thank you for your time.
Thank you.
All right. And for the audience, we're going to take a 15-minute coffee break, and we will be back at 11 Eastern.